So a good question is, why are there 360 degrees in a circle? Seems kind of weird. And there's a couple possible answers here. One of them that's kind of nice is that 360 is divisible by a lot of different things. There's a lot of things that go into 360. So it has a lot of factors. It's called highly composite is what it's called. On the other hand, a number that might feel more natural, like 100, well, that's not evenly divisible by 3. So, a little knock on 100. So that's one possible answer. The other possible answer is that the Babylonians used to use a base 60 number system. And so here's some of those Babylonian numbers. And that, 6 times 60 is 360. So it worked out pretty nice in their base system. Maybe that's a possibility as well. And of course, 6 equilateral triangles, you can kind of pull them together and fit them neatly inside of a circle. So maybe that's the answer. Personally, I kind of like this one, although maybe it's less likely. The number of days in a year. 365, so we'll go 360 because 360 is divisible by a lot more things. Maybe that's why. Or maybe because 365 and 355, the number of days in a lunar calendar, if you average them, you get 360. Who knows? So a couple different possibilities there, but the reason we're concerned with circles is because we're going to use them in working with angles. So let me come over here and talk about angles, and in particular, angles in standard position. Whoops, where'd that? Didn't mean that one to come up there. So this is section 2.1. And by the way, you might notice that we're not really doing any review. This course is starting with new material day 1. The review stuff that I might need, I'll do kind of just in time. It's like, okay, do you remember the distance formula? And I'll talk about the distance formula when we use it. But I'll just review the topics we need to as needed. So what I'm going to draw is an angle in standard position. So this is what's called the initial side. And this is the terminal side. And naturally, in a trig class, we're going to use Greek letters to denote our angles. So you're going to learn a lot of Greek letters. And the one we'll start with is theta. So it looks like a circle with a belt around its waist. So, or maybe an O with a belt around its waist. So that's the Greek letter theta. Now that initial side is typically laid on the x-axis. So, like that here, and this here. And there's some interesting things that can happen when you're working with your angles. Now, of course, all the way around, that's your 360. Let's see. So, for those of you at home, I put out these handouts online. Those of you here, you've got some here. These angles here are kind of special angles. And I'll start out with this one right here. We're going to use these angles a lot. So that one's a 30-degree angle. How about this one due north? If I started out here for my angle in standard position and went straight up, then I'm 1/4 of the way around a circle. So what's 1/4 of a 360-degree angle? 90 degrees. Good. So this is 90 degrees up here. And then we've got a couple other in between. What's halfway between, say, 0 degrees, which is right here on the x-axis? Halfway between 0 and 90 would be this one right here. What's that angle going to be?
45.
Yeah, 45. Thank you. All right, so that one's going to be 45. Any guesses as to, so that's my 30, 45. Any guesses as to what that one's going to be? 60. Nice. So that one's 60. So these angles are going to get used an awful lot. In fact, at some point, I'm going to give you a blank unit circle and ask you to fill in not only the angles in degrees, but the angles in some other unit called radians. We're going to spend a little time working with radians. Now, there's some interesting things that can happen when you're working with angles, and that is you can go more than once around the unit circle. So, for instance, if we wanted to look at, let's see, 420 degrees. Let's think about how I would draw 420 degrees. Well, I'm going to start with my initial side right here. That's your angle in standard position with initial size on the positive x-axis. And then 420 degrees means once around. How far is once around? 360. So if I subtract off 360, that leaves another 60 degrees. So it's once around and then another 60 degrees. So right to there. And that's going to be where I draw the terminal side for my angle in standard position. So it's equivalent to a 60-degree angle, but it really has an extra loop around the circle here. So that's 420 degrees right there. What else could I look at? Well, good question. What do you think I would do if I had a negative 135 degree angle? How should I draw that? Yeah, you go the other way. So you're going to go clockwise instead of counterclockwise. So negative 135, well, that's negative 90 is down here, and then I need to go another 45. So that other 45 is going to put me right here. So that's your negative 135 degree angle, is that one right there, negative 135. Nice, nice. Why don't you try one? Let's see. How about, let me do 210. 210 degrees. Now let's think a little bit about 210 and an angle that you're going to pass along the way. One of the angles you're going to pass on the way to get to 210 is 180 degrees. What's special about 180 degrees? Yeah, it's halfway around the circle, right? So if you go halfway around the circle, starting out here, halfway around the circle is going to put you right here. But halfway around the circle is not quite far enough. So let's take a look here. How far do I have to go past halfway around the circle? Yeah, another 30 degrees. So that's going to be right here. So starting out here, your 210 degree angle would put you right there. Okay, nice, nice. Let me give you a moment to try one. 495 degrees. Let's figure out where that would be, how you would draw that one. Again, start out in standard position. So that's with the terminal side or initial side on the x-axis. And then figure out where that's going to land you. Now, while you're working on that, let me just note for you or remind you that this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. those of you at home can, let's see, I think I can probably just put you a Desmos link in the chat. Those of you here, we're going to go to radian measure in just a moment. And then I think it should be on the back of your handout there for section 2.1. You can do the QR code and jump to the Desmos link here that I've got for you. But let's put in some answers here for this one. 495 degrees. Where is that going to be? What quadrant? 1, 2, 3, or 4? You were holding that sideways. 2. Okay, that's what I thought. That's what. Yeah, second quadrant. Good, because 495 can be thought of as 360, which is once around, plus 135, and it's that extra 135 that we want to get to. So that's going to be your terminal side. Although the angle, if you actually did rotate through that, is going to look like this. Start out here and then end up there. Nice. Now, degrees is what everyone's familiar with. Degrees is a very friendly way to work with angles. Unfortunately, it's not the unit of measure we're going to need when we get to higher levels of mathematics. We're going to need another one called radian measure. So what on earth could radian measure be? Well, let's open up a little Desmos presentation here. And I'm going to copy this and put it in the chat for everyone that's doing this at home. And you know what? Let me open my video up. Let's see. Chat. Send that to everyone there. For those of you who are here, hey, you can do a QR code. Scan that in. It's on the back of your handout. And open up that link as well, so you can kind of play around with the same thing I'm playing with. So what I've got here is the unit circle, and we're going to use this a ton. Now let me remind you of some things about the unit circle and the equation that goes with the unit circle. So real quickly, unit circle has this as an equation. X squared plus y squared equals 1. Center at 0, 0. Radius is the square root of 1, which is still 1. So that's the equation that traces out the unit circle. And what was going to have going for it is that this distance here from the center to the edge is exactly 1. That's very nice, very handy. And what we're going to do with radian measure is, instead of looking at angles in degrees, we're going to count how many times I'd have to lay that distance of 1 along the outside edge of a circle in order to reach a certain distance or a certain angle. So for instance, if I took this unit of length, this radius, and I stretched it out on the circle all the way to a distance of 1, it would take me to this angle right here. And so let's see that. Let's see where a distance of 1 would take me. So you can take this slider here and kind of move it, and take a look at the little a up there. When a gets to 1, we've gone exactly 1 radius, or 1 radian. Now 1 radian turns out to be about 57.3 degrees. Okay. If you want to go to 2 radians, well, you can keep on going. And there's 2 radians. I went past it a little bit. 2 radians. Nice. How many radians do you think it's going to take to get halfway around the circle? That's a good question. Yeah, it's a little bit more than 3. And somebody ventured a guess here. Go ahead, say it a little louder. How many radians, how many radii am I going to need to stretch out across the unit circle to get halfway around? Pi. Pi radians. Beautiful. And that leads us to an important equation here. There's not really much of an equation, it's just kind of an equivalency. And that is 180 degrees equals pi. Now you're asking about what things I need to memorize. This one first and foremost, because this is going to allow us to convert between angles in radians and angles in degrees. Now, there's no doubt that working in degrees is more comfortable. It's even more comfortable for me. I don't tend to think in radians. It's kind of like Spanish. You know, I'm somewhat fluent in Spanish, but I have to think in English and translate to Spanish. I have to think in degrees and translate to radians. I can't really think in radians as well as I can in degrees. So that's where this comes in handy. Because if you had something in radians or degrees and you wanted to go from one to the other, you can simply multiply. I can take this relationship and divide both sides by pi and then get 180 degrees divided by pi. And that's going to allow me to convert from radians to degrees. Or, if I do things the other way around, pi over 180. Again, that's going to allow me to do some conversions. Notice that each of these is a fancy name for the number 1. Because pi, as an angle, is 180 degrees. So if you multiply by this one or this one, effectively you're multiplying by 1. And hopefully you choose the correct ratio so that the units you want to get rid of are in the denominator. They'll cancel out. So that's the idea on converting there. And let's actually practice that a little bit. But let's finish our little decimals demonstration first. So let's keep going. And then you get to this point right here, which is 270 degrees, or it's 3 pi over 2. How about all the way around? How many radians is that? Any suggestions? Yeah, 2 pi. And you can see that right here. But hopefully you can figure out, oh, well, if halfway around is 1 pi, then all the way around is 2 pi. So that's your thing in radians. And of course, you can divide it up into any different way that you want. Like I said, let's practice converting a few of these things. And by the way, feel free to ooh and ah. These are cool demonstrations. That's nice. I like that. Wow, ooh, ah. All right, you're going to have to practice that. I want you guys better by the end of the semester on that. In any case, let's do some conversions. Let's start out with some familiar things and work to the unfamiliar things. So let's convert 30 degrees to radians. All right, it might help if I click over here on the screen. That's a little bit better. Convert 30 degrees to radians. So the thing is, you've got two different ratios that you can use. Let me call them A and B. A and B. But the ratio you want to choose is the one that has the units you want to cancel in the denominator. So I'm going to choose this one. So I'll multiply by pi over 180 degrees. Now something nice happens here. A couple nice things. First of all, units of degrees cancels. And the other thing is 30 goes into 180 evenly, right? How many times? How many times does 30 go into 180? 6. So I get a 1 here and a 6 here. So 1 times pi over 6, this is just going to be pi over 6. So pi over 6, that's your angle in radians. That's a 30-degree angle. It's just in radians. Radians is the language that calculus speaks in. Because without radians, things are a lot messier. So let's try another one. Let's try, let's think here. Let's try 495 degrees. 495 times something. Well, if that's in degrees, I want to multiply by the same thing I did just a moment ago. Pi over 180. And just like what I had just a minute ago, units of degrees is going to cancel out. All right. Well, it's going to leave me with 495 over 180 pi. And you can write the pi in the numerator or leave it next to it. You can't write it in the denominator. But I'd probably want that in lowest terms. Now, if this was, say, a pre-algebra class, I'd be worried about you showing your work and doing it right. But this is trigonometry. I don't care if you want to take and show me the work of dividing and putting in lowest terms or not. Here's my suggestion. Let's just do it on the calculator. 485 divided by 180. And then you can hit the math key over here. Hit the math key and then press enter twice. And it turns that into a nice fraction in lowest terms. Ooh, that's pretty cool. I like that. So what I'd like to see from you on an exam is you write that as, 11/4 pi. 11 pi over 4 or 11 over 4 times pi. You just can't write the pi in the denominator. At that point, it'd be wrong. You can write it next to it or in the numerator, but not in the denominator. Okay. How are we doing so far? Doing good? Thumbs up? All right. Thank you. Thank you. How about my homies? Doing good out there? All right. Nice to see some cameras on. Let's see here. Let's try some more here. So, for instance, in fact, let me give you 2 to try, and I'm going to walk around, try and learn some names, and let you work on this as well. If you're watching this later, you can kind of skip past some of this stuff a little bit until I resume my lecture. So let's do negative 240 degrees. Let's turn that into an angle in radians. And let's also do negative 90 degrees. Turn that one into an angle in radians. So give that a shot. Whatever you want. Here. Yeah. So this is my low-tech pause button if you're watching this later. this one. So kind of like some of these other ones, we want to multiply by pi over 180. Units of pi is going to cancel itself out, or units of degrees will cancel itself out. 240 over 180. And don't forget the negative sign. So it's going to be negative. Does anyone know a big number that goes into both 240 and 180? It'd be 60. But if you don't know that, that's okay. And you do negative 240 divided by 180. And then hit the math key. And it's going to tell you what I just told you, is that 60 goes in there 4 times for the numerator, 3 times for the denominator. Don't forget the units of pi. So it's going to be minus 4 pi over 3. Or you could write it as minus 4/3 times pi. Nice. How about negative 90? What'd you get on that one? William? What'd you get when we converted that to? Perfect. So degrees cancel. 90 goes into 90 once and into 180 twice. So it should be negative pi over 2. Pi over 2, negative pi over 2, those are going to come up a lot. So it's helpful to get familiar with them. But in doing the homework, you are going to get familiar with them. Let's try some in the other direction. So for instance, how about this one? Let's try 5 pi over 6. And I want to convert that to degrees. So, okay. But wait a minute. What do I want to multiply by in this case? 180 over pi. Yeah, 180 over pi. The units that you want to cancel are going to go in the denominator. In this case, that's pi. So, thank you, James. Now, units of pi do cancel, so that's good. And I get some more cancellation. You might notice that 6 goes into 6 once and into 180 30 times. So what I'll end up with is 5 times 30 is 150 degrees. Yay! Let's keep going. Let's try one. Kind of like doing problems every now and then that I just don't know the answer off the top of my head by looking at it. And that would be this one, 3 pi over 30. Oh, excuse me, 3 pi over 20. My bad. 3 pi over 20. I was going to say 3 pi over 30. You should put that in lowest terms. 3 pi over 20. So that 3 never happened. It's actually been a 2 in disguise. Kind of like the last one, I'm going to multiply by 180 over pi. That's 180 degrees there. Units of pi cancels out. So that's nice. What other kind of cancellation do I get? 20 into 180. 20 goes into 20 once, and then 180 9 times. So I'm left with 3 times 9 is 27 degrees. Now, I was mentioning something like this in my calculus class earlier today. It says, a problem that I like for an exam. All right, so I hope that's kind of like loud enough and clear enough. One that usually finds its way on an exam is something like this. Convert 3 to degrees. Now, what's troubling about this, especially as you're getting used to trig, is that, wait a minute, there's no pi, right? It's like, well, where's the pi? There's no units of pi. Well, you're right, there is no units of pi. But let's think back to our demonstration on radians. Here. Each radian is about 57.3 degrees. So if I had 3 of them, well, it should be somewhere over here, 3 radians. This should be close to, but not quite, 180 degrees, right? So that's what you're expecting, is something close to 180 degrees. Now, even though it doesn't have pi, don't put pi in there. The reason I'm taking time with this is because almost always people want to put pi in here on the test before they convert it to degrees. It's not there. You're just going to multiply by 180 degrees over pi, and there's no cancellation with pi, so it's okay. 3 times 180 is 540 degrees over pi, and that one we're going to do on our calculators. So let's clear out a bunch of this stuff. Clear out this. 540 divided by pi. And you should never have to type in 3.14159256593. Okay, I'm showing off, but divide by pi. You hit the second key, then the up arrow key. That's where the symbol for pi is. So right above that exponent key. There we go. That's not a surprise. We expected something close to 180 degrees. 172.887. 172.887. Be careful when you enter your answers in homework. It's going to want you to round them if you're not doing with an exact number. So, round appropriately. Okay, I think we're good on that. Now, units of degrees can get really, really big, especially if you're talking about something that's really, really far away, like the sun or a nearby star. In fact, if you were to look at the sun, and I can't quite remember the exact angle, but I think it's pretty small. I don't know, let's just Google it. So let's see over here. What angle does the sun make with the eye? Let's see if we can get at that. Angle tilt, no, that's not what I want. I just want to know how big the sun is when you look at it. I think it's much less than a degree, because the sun is really, really far away. And when you move really, really far, then those angles can represent big distances. So what I'm looking at is the top of the sun and the bottom of the sun. And I think that that's a really slender angle. And I just don't want to go out on a limb and give you the wrong information. So maybe somebody can look that up and get back to me. But the units of degrees become too big. And so we have to divide things up. So we can do that. And 1 degree is going to be divided up into 60 equal parts. So we're getting back to that number 60 that the Babylonians dealt with as their base. 60 minutes. 1 degree is 60 minutes. And then units of minutes is also too big sometimes. So we got to divide that up. So 1 minute, any guesses? 60 seconds. 60 seconds. And the unit of a second, an arc second, is pretty small. It's 1/3600th of a degree. It's a slender angle. So if you looked at the angle that your eyesight to a human hair would make over a distance of a couple miles. So move a human hair out a couple miles and look at it. Top and bottom is going to make an angle of about 1 arc second. It's really slender. But you use these things in astronomy and other places all the time. So let's get familiar with it a little bit. And let's start with, let's take this example. Start with 41 degrees, 10 minutes, and 24 seconds. And I want to convert this to degrees. all degrees. I don't want any minutes, seconds, any of that stuff. I just want to convert it all to degrees. So what you have to do is you have to start out with the smallest unit first, convert that to minutes, and then convert the whole thing to degrees. So let's start out with 24 minutes. And I got to figure out, well, what am I going to multiply by to convert that from seconds to minutes? And the key thing that you have here going for you is that you already know how these things are related. 1 minute is 60 seconds. But can you use the stuff that we did earlier to try and figure out, well, what do I have to multiply by? It's going to be one of them over the other. But which way? What's going to go on top? What's going to go on the bottom? Seconds on the bottom. Perfect. Because that's the unit that I want to cancel. Awesome. Thank you, Sydney. And then the units that I want, that's going to be 1 minute. So perfect. Let's do that cancellation. Units of minutes, or units of seconds, I should say, cancels. And you're left with 24 over 60. And that's all in minutes. And that looks like a number 1 rather than a little hash. So let me just do that again. Now, it's frustrating. That notation also stands for what? Feet. Yeah. Nothing much I can do about it. It's just the notation we use. But 24 over 60 reduces to 0.4. So yay. Now, the nice thing about what we just did is I can take this two and combine them now. Instead of saying 10 minutes, 24 seconds, I can regard that as 41 degrees and 10.4 minutes. So I got rid of my units of seconds here. And now I'm going to change units of minutes to degrees so I can write the whole thing in degrees. So let's see about that. So let's do 10.4 minutes. And again, I've got to multiply by something. I've got to multiply by the number 1. What form of the number 1 am I going to use this time? We don't have to go all the way up to 360. Is it just still 1 over 60? Yeah, it's 1 over 60. Good. So it's 1 degree is 60 minutes. And that goes back to this bit up here. 1 degree is 60 minutes. If I want to get rid of units of minutes and end up with degrees, I put units of minutes in the denominator. Units of minutes cancels. I'm going to be left with 10.4 over 60, and that's all going to be in units of degrees. And at this point, now I am going to take out my calculator. I should get something near about 0.19, but I don't know exactly where. So let's just see. 10.4 divided by 60. I was off. I thought it was 0.19. Okay. So I was off. So about 0.173333, etc. And you can round it anywhere you need. So about 0.17333, etc. But now I can put that onto this number and finish off my problem. It's going to be 41.17333 ... And you can round that to, like I said, anything you need. Let's do 0.173 degrees. So same angle, you just now broken it up into, or you've changed it from minutes and seconds to just in degrees. Looking good on that one. Some thumbs up from my homers. Sarah looking good there. Brittany, still with us? Okay. Do you want another one like that? You want to practice another one like that? Okay. All right. Let's do one. Mhm. So let's take 61 degrees, 42 minutes, and 21 seconds, and convert that to just degrees. And I'll give you a minute to work on it. If you're working on it at home, great. You can pause the video if you're watching this later and fast forward when you're done. I'm going to walk around and see if people need some help. Does anyone need to borrow a calculator here today? If you need one, come on up and borrow one. Just leave me a set of keys or a phone, something you're not going to leave the classroom without, and you got a calculator to borrow for the day. If you got something other than a Texas Instrument, hey, that's great. You don't have to sell it or anything like that, but I'm not going to be exceptionally helpful in figuring out how to use that stuff. There's a lot of other great calculators. You can't use a TI Inspire on the exam.
It's got the 84 base on it though.
I'll take it.
No, check it.
Assume that was 0.705.
Yeah.
Okay. All right. So my homers, you can put your answers in the chat to me privately while I work on this over here. But I want to see you guys putting some answers in the chat for me, please. Thank you. So we're going to start with the smallest unit, which is our 21 degrees, or 21 seconds, I should say, and times by should be 1 minute over 20 or over 60 seconds. So 1 minute over 60 seconds. And the units of minutes are going to cancel, so I'm going to be left with 21 over 60, and that's going to be in units of minutes. Now, I think that was 0.35. Is that right? 0.35. So that means I could take this piece right here and rewrite it as 61 degrees and 42.35 minutes. Now I'm going to work with this chunk right here, and convert that from minutes to degrees. So let's take 42.35 minutes times 1 degree over 60 minutes. Units of minutes is going to cancel out, so it's just 42.35 divided by 60, and that's going to be in units of degrees. I think that was 0.705 something. Was it 3.83? All right, beautiful. So if I tack that onto this part right here, so I'll get 61.70, we'll call it 6 degrees. Yay. Nice. So, hopefully an easier problem on an exam, if you got one like that. Let's try the other way. Let's start out with something in units of degrees and turn it into degrees, minutes, and seconds. So we'll go the other direction. So if you're following along doing some of the homework problems, then this would be problem number 68. So it's going to be 29.411 degrees. And to convert this to degrees, minutes, and seconds, what I'm going to do is start out with the fractional part, 0.411 degrees. And I want to convert that first to minutes. So, okay. If I'm going to convert to minutes, then what unit am I getting rid of? Degrees. So that's going to be in the denominator. So it's going to be 1 degree in the denominator and 60 minutes in the numerator. Now, do you have to write this? No. But I'll tell you what, people that don't write it, they often use the wrong conversion factor. And they often end up with the wrong number because you can't see what you're doing. But here you can see, oh, units of degrees cancels, and I'm going to end up with units of minutes. So it's going to be, what, 24.66 or something like that? All right, thank you. So it's going to be 24.66, and that's in minutes. So now we've got 29 degrees, 24.66 minutes. Great. But I'm going to work with that fractional part. Let's work with the 0.66. 0.66 is in minutes. I want to get to seconds. So 1 minute in the denominator is 60 seconds in the numerator. Again, you get that cancellation that you like. Units of minutes is going to cancel itself out. Let me find a correct implement of math instruction. There we go. 0.66 times 60, I think, is 39.6. All right, so 39.6 seconds. So when it's all said and done, this is going to be 29 degrees, 24 minutes, and 39.6 seconds. Yay. Nice. So it's a very, very, this is a very, very small portion of an angle when you're getting down into tenths of a second. It's a really slender degree. All right. Looking good there. Let's see here. Yeah, we've been going for a little bit more than an hour, haven't we? So let's pause and take a quick break. And I'll see you back here in about 6 or 7 minutes. So we'll continue with section 2.1 in just a little bit.